but for a computer it just sees array of elements. From this array of elements, we want to make inference of what are all objects available, where objects are, and where the object boundaries are, which objects are present, okay, and then what is the interaction between the objects, and understand the scene. This is the problem of image processing to computer vision. Essentially, image processing, what it does is, the input is an image and output is also an image in image processing. See, for example, if I get an image from the satellite, it comes with a noise, which is referred to as synthetic aperture radar based sensors will be there, SAR based interferometry based noise will be there. So that is referred to as speckle noise. So in such case, how do we make the image noise free? Or when a car is moving, I will get a blurred image, okay, smeared image. How do I make an image better, look better? Like we do usually in Photoshop, okay, our people does in Photoshop. Okay, there are several inbuilt things that are available they will be moving here and there and so on, right? So what are they moving is they are increasing the contrast, they are changing the proportion of the input to the output, each pixel, how much intensity should it take, they will keep be changing, something like that. So that is image processing. Whereas computer vision, like the vision humans has, the ability to infer should be there in a computer vision algorithm. So essentially, if I give input as the image or a set of images or a video, how do we infer from what's happening there? Which are objects available there? Where are they? Okay, all these things are the questions posed, okay, in computer vision and will be answered from should be answered to be answered from the videos. That's what computer vision field is. Since we need to deal with inference, okay, we need a kind of understanding or learning. Okay, so that's where the machine learning comes into the picture. Okay, so now let's see some of the very basic tasks. The basic tasks, of course, I may go little slowly on few initial things which I feel as the ground. Okay, and then I will move on little faster. Okay, at the later point. Okay, even if you feel that you don't understand some of the points, okay, no need to bother. Of course, my video lectures are also available, and many other faculty have given their video lectures, which are probably in their academic institutes, and you can go through them at more length. But here, some ideas I would like to float on, so that you get a better understanding of them later, or you can build upon them. So essentially, if I want to extract some information or some inference from an image, what I want to do is, for example, I want to know how many objects are there, how many persons are there in this room. I have taken a snapshot of the class and I want to know how many persons are here. So what do? The immediate task is, I want to say separate each object or each person. How do I do that? I need to get the object boundaries. How do I get that? How do I get this? I need to get where object boundaries are those where sudden transition of intensities happen. So for example, if I am standing, okay, behind me there is a white wall or a black wall, okay, there will be sudden transition of intensities at the boundaries. Okay, similarly between objects and between different persons. So the object boundaries, how do we get is the question. How do we get? Essentially the transition of intensities where there is a jump from, okay, either high intensity to low intensity or low intensity to high intensity. Such transitions are referred to as the object boundaries. Those can be referred to as edges in image processing. Okay, so how do I extract them? I want to find out the gradient or the variation in intensity. From here to here there should be high change, right? Or from here to here there is a high change. If I want to extract some kind of features or enhance some kind of features, the technique in image processing is, okay, you design a kernel or a filter of that nature and perform correlation or convolution. Okay, those who are familiar with signals and systems and signal processing should be very familiar with convolution operation. So what do we do in convolution? Okay, if I have an input, if I have a system with some impulse response, okay, if I want to get its output, essentially I will be giving an input and the system impulse response is used for convolution to get the output. Here the system itself is a filter, okay, through which I want to pass the input. Okay, if I pass this input through this filter, what this filter or system should do, it should highlight the sudden transition regions. Wherever there is a, see, if you see this filter this filter itself looks like say minus to negative. Okay, minus 1 to plus 1, there is a transition, right? This is the sudden transition. Okay, and then here there is a sudden transition across this row, horizontal. Okay, row, and here there is a sudden transition along vertical direction. So if I convolve this image with this filter, what it does, wherever there are sudden transitions in the vertical edges, it highlights. Okay, if I convolve with this filter, it will be highlighting horizontal edges. Okay, highlighting means it gets, okay, those values will be higher at that locations. Then if I perform a thresholding without sign, okay, I will be getting the edges. That is how usually is done. So if I want to extract or highlight some features, the conventional way in image processing is to pick up a filter of that sort, okay, and then perform a convolution operation, okay, and in the output you get those things highlighted, so you threshold to see only those things, right? So now a question. Assume that I want to highlight only corner points. Okay, I am interested only in corner points. What kind of filter should I have? What kind of filter do you suggest to have? Only corner points I want. Okay, I assume that there is the image is like this and I want to highlight wherever the transition of the sofas are. Okay, or where is this for this camera? Okay, the peak of the. So if I want to highlight corner points, okay, how should be the filter? Any guess? Also, I assume even though you are teachers, okay, I am also a teacher, okay, in the class you can participate. Also, how should be the filter? Filter should also have a sudden transition. Okay, what is a filter? 3x3 filter having sudden transition. So you can put some high value in between, okay, and put a lower values, okay, around. That's the sudden transition. So 4 I can put, or 8 I put in between, -1, -1 I will put here. Okay, so 8 is a sudden transition compared to all -1s, right? So that's why that if I convolve with such filter, what will happen? It will highlight all the key points. It will highlight all corner points. Okay, corner points will get, see wherever corners are there, they are 8 times lower or 8 times higher. Okay, compared to the neighborhood, right? So I highlight. So now the next question. Okay, of course there may be some slides or may not be. See, if I want to highlight face, okay, in a image, I have taken a snapshot of the class and I want to know where the faces are. I want to detect the faces. Okay, what kind of template should we have? Some of the face features has to be there. Okay, which are the prominent face features? Eyes and then probably, okay, the forehead or the eyes and this region. Okay, so eyes are darker compared to any other regions. So you should have a dark here and bright here or bright here, right? Similarly, compared to the nose, eyes are again darker. Okay, so you should have dark and in between white. If I create such templates and perform convolution operations, okay, what I am going to do is, in the eyes, wherever the eyes region, I will be getting a high value. Okay, so I can detect the faces. That's what is used in our cameras. Okay, so essentially the Viola Jones has proposed a nice method for face detection. Okay, Viola Jones face detection, it is very well known. It does in real time. Okay, the features that it extracts are essentially the additions and subtractions between the neighborhood regions. Okay, it puts two dark regions and in between white region, that is one kind of filter. Other filter is white, okay, and dark. That's all. Okay, so of course there are several other filters it uses, but these are the two prominent filters based on which the decision is taken. Okay, so like that. So if I want to design, if I want to come up with any application, okay, leaving the deep learning or machine learning and all, I just for an application where I have a point target detection. Okay, so the drones are flying or some aeroplanes are flying, okay, or missiles are flying, okay, shooting, okay, we have a image and it looks like a point.